briefly, is kind of like a roadmap for how we can convert between anything that we'll find in a given stoichiometry problem. So if you're given, like in this one, if you're given grams of methane, right, we can start with a mass, right? We can actually do this on either end, but usually X is what you start with. So mass of X, right? And we need to find moles of Y. Okay, but before we can talk about CO2, we have to convert between the two moles using a magic mole ratio for that middle step. Okay, so first it goes mass of X, converting to moles of X. But before we can even talk about Y, we need to convert using a magic mole ratio. All right, so great job, everyone. And that will seem more clear as we practice it today. But for now, everyone, please just remember to not share any personal information during class. Your participation is always required. And we are recording these sessions for learning purposes. All right, that's an extra slide. But today is Wednesday, so remember that tomorrow is a recording day. All right, which looks like, again, we're using it to complete missing or failed work, which means for us, right, if you're someone that still needs to complete any of the projects that we have done, right, over the past trimester, please get those done and turned in, all right, because Mrs. Larkin is only going to be here for the rest of this week, and she is still offering tutoring sessions for the rest of this week as well. So we only have a couple more lessons left in this unit, moving right along, and we're going to remind you about the STAR 360 tests.
All right, so again, STAR 360 is happening next week on Tuesday and Wednesday. So Tuesday during our period, so you'll be in our class getting your STAR 360 done. And math will be then in your whatever you have for period 3 on your on Wednesday, okay? So keep in mind that you're still responsible for completing the lesson. So if you miss a class, please make sure that you watch the recording for whichever class you're missing Tuesday, Wednesday, and make sure that you still do your assignments. For our class specifically, you'll still need to be able to do your notes once the recording is posted. Okay. Remember that because we were originally going to have an exam on this day, we did instead alter the schedule. So taking a look here, we're going to go straight from Unit 4 to Unit 5, and instead of a final exam and a Unit 4 exam, we've just combined them into the Unit 4-5 exam. Go ahead and give me a green check, orange X, everyone, if that makes sense. Again, it's all just being combined into one thing. Thank you, Allie, Julie. Waiting on green checks, Andrew, Kathy. Let's get green checks, Callie, and Jaden. Excellent. Thank you, Landon, in the chat. Beautiful. That's everyone. Let's go ahead and move on here. Again, yes, as mentioned, I am going on maternity leave in just a few days. I do have office hours today, tomorrow, and Friday, but that's it to help you with your projects. After that, I won't be available. So please make sure you come today, tomorrow, Friday if you need help on projects. Again, highly recommend that you have those completed before I leave to make sure that you are all squared away and as caught up as possible before I do leave. Because again, with a sub coming in, they might not be as familiar with the content, and so they can maybe help you, but it's going to be a little bit harder. So make sure come to office hours, okay? Let's go ahead and go over objectives.
So again, because this is a part 2 of the lesson we started yesterday, we're still working with those coefficients, using those balanced chemical equations and converting between moles and mass. All right. So let's go ahead and take out our notes. All right. I already see many of you have raised your hand. But let me start.
Cool. All right. So today we're going to go ahead and continue with our stoichiometry. We've been doing this a lot. You just have a few more days of it. I know it's math heavy stuff, but let's just review again how to make a mole ratio and how to make a conversion ratio with molar mass. Taking a look here, what is the mole ratio for ethane and oxygen? So we see ethane right here. What is the moles? How many moles of ethane are in our equation? Go ahead, tell me in the chat. Look at that big coefficient in front. Big coefficients are moles. Big coefficients are moles. Thank you, Landon, in the chat. I see Micah. Let's get Callie. Thank you, Ronnie. Let's get Marina. Kathy, John. Thank you, John. Thank you, Marina. Beautiful, Monse. Yeah, exactly. We can see its coefficient is a 2. And we want to know its relationship to oxygen. Take a look at its coefficient. Tell me in the chat how many moles of O2 are here. How many moles of O2 are here? Excellent. Yes, there are 7. We can see its coefficient is a 7, so that goes right here next to moles of O2. Now again, depending on what you're solving for, that's what goes on top. So in this case, I would be solving for moles of ethane from moles of O2, okay? But I could flip this and instead solve for the opposite. So if I want to solve for O2 from moles of methane, then I would put the O2 on top with its 7 and the ethane on the bottom with its 2. So again, it looks the same, just flipped upside down. Smiley faces, emojis, everyone, if you feel comfortable with that. Again, we've done this several times from our equations. Remember, mole ratios, moles to moles, must always come from equations. Great. Now, on the other hand, if we want to go from moles to mass or mass to moles, then we need something that includes both moles and mass, hence molar mass. Again, we always have to use something that's standardized and always true, and molar masses are something that's standardized and always true. So this is how we get from moles to mass or mass to moles. Taking a look here, ethane's molar mass is 30.07 grams per mole. So we need to figure out, remember that we have a dash here. Dashes are just fractions in disguise. So you can see the same dash right here. So we've just moved it into fraction form. What number should go next to grams on top? Tell me in the chat. Let's imagine we're solving for grams on top from moles on the bottom. What number should go next to grams? Take a look at the molar mass. Again, when we're talking about conversions, the number next to grams should not come from the problem. It should come from the molar mass, something that's standardized and always true. Thank you, Micah. Thank you, Landon. Need more answers. Ali, Elijah, Andrew, Douglas, Karime, Jessica, Narish, Jaden, Mary Jane, Dima, David. Thank you, Marina. Thank you, Andrew. Beautiful. Yeah, so right there we can see 30.07. That goes on top. And on the bottom, what number should go next to moles? You'll notice here that it's per mole. It's a blank. Blanks mean what? Per how many moles? Yeah, it just means per 1 mole. Easy peasy, all right? Just like 30 miles per hour means you travel 30 miles in 1 hour, per 1 hour. Now again, same thing here. If I instead want to solve for moles of ethane from grams of ethane, I just flip it. So the 1 still goes next to moles, and the 30.07 grams still 30.07 still goes next to grams, just now on the bottom. All right. Number 3 is a little bit tricky, so I'm going to talk about that in just a moment. But number 2 is not bad. Number 2, again, look for where you have a fraction that includes a 2 and a 7. All right, check off both of them. Right, so you should have 2 answers for number 2. There should be a 2 moles ethane on top, 7 moles oxygen on the bottom, and then flipped. Now this one over here on the right is a little bit trickier because the numbers are the same throughout every fraction. The only issue is what units are the numbers next to. So make sure that 30.07 is next to grams on top, and 1 is next to moles on the bottom, and then flip it. Make sure that you have a 1 next to moles on top and a 30.07 next to grams on the bottom. I promise you, they're both there. You just got to read carefully. I know it's a little bit, there's a lot of them that look similar, so you just need to read it carefully. All right, this is number 2 and number 3. Go ahead and raise your hands. I'll give you 40 seconds. Again, read that third one very carefully. You have to check the units. The numbers don't change. You have to check the units.
Mole roadmap for just a second, right? So we have 2 different calculations that we can use this roadmap for. We have converting between grams and moles for the same chemical. So say we have like something like water, right? If we're given a mass of water, right? Something like 10 grams of water, then all we would need to convert it to moles of water is to calculate the molar mass for water itself, right? And we can all day just convert between moles and mass, vice versa, as much as we want. But the only way to convert between moles of different substances or compounds, right, between mole of X and mole of Y, is using that magic mole ratio. Okay, so, and where we get that, right, is always from the chemical equation. It's going to have those large coefficients in front of it where we're going to create a fraction based off of those large coefficients that are in front of those particular chemicals. Okay. So we will use that in the future in a little bit here, but for number 4, we're going to write the word different. Word different for number 4. We're going to try to minimize the time we spend on this one so we have more time for the actual questions where we're doing math and learning the process. So please quickly just type in the word different on your notes and raise your hand.
Awesome. All right, everyone. So let's go ahead and actually work on this. So taking a look here, how many moles of oxygen, O2, are needed to react with 75 grams of ethane, C2H6? This is the same equation that we've been working with so far, as well as you can see the molar mass that we were working with earlier. So taking a look at our actual question, though, what am I starting with? Give me number, give me units, give me chemical. Remember, we need all three to be specific enough so that we know what we're talking about. We need a number, units, and a chemical. Go ahead and tell me in the chat. Excellent. I see Micah coming in. I know it takes a little bit of time to type them, so I'll give you time to type. Awesome. I see Andrew with the number. Make sure, again, include the units and the chemical as well, right? I see people identifying the number, but we also need units and chemical. Because remember, you could have any units, you could have grams, moles, right? Or you could have any chemicals, so we got to be specific. Yeah, exactly. So this is what we're going to be starting with right here. That's awesome. All right, and taking a look down here, that means that I am starting on, I always make my starting one the pink side, so that's going to be my C2H6 over here on the pink side. And so point for me up on the board, would I be starting with mass or moles? If I have 75 grams, is that a mass or moles? Point for me up on the whiteboard. Thank you. I see red up there, purple, pink, I see you. Let's get some greens and yellows up there. Let's go, let's go. Thank you, green. There we go. Still waiting on a few more answers. Awesome. Thank you. Awesome. I even see another purple. Love it. Yes, this is where we are starting up here. We're starting at mass of our ethane. Now, what am I ending with? Tell me in the chat. What am I ending with? Look at the question words. How many what? Give me units, give me chemical. Units and chemical. Thank you, Micah. Thank you, Ronnie. Waiting on some more participation. Josiah, Angelo, John, David, Dima, Jaden, Nareesh, Jessica, Kathy. Awesome. Yeah, so we're solving for moles of oxygen. Now, is that the same chemical or a new chemical? Tell me in the chat. If I start with ethane and end with oxygen, is that the same chemical or a new chemical? Yeah, this is going to be our new chemical. So I'm going to make the new side, the blue side, my oxygen. And again, we're solving for moles, so that would make this my last step. Smiley faces, emojis in the chat, everyone, if you feel comfortable with that. I'm not getting all the way over to mass. I'm only getting to moles here. Great. Now point for me on the board. What's my middle step? What's my middle step then? We should know how to do this. We've practiced this several times now. Thank you, red, purple. I see you. The pink's up there. Let's get some yellows and greens. Excellent. There we go. Yes. Perfect. Yeah, our middle step right there would be first we have to get to moles of our starting chemical. Remember, you cannot go straight from grams to moles of something different. You first have to get to moles of your starting chemical before you can change to moles of a different chemical. So let's go ahead and check this out. We've got 75 grams of C2H6 on the top here. I want to turn it into a fraction. I'm going to put it over 1. In the next step, grams of C2H6 needs to go where to get rid of it? Where does it need to go to get rid of it? As always, on the bottom, yes. Now, on the top, what am I solving for in this middle step? Again, I mentioned we have new units, but it should be the same chemical. So give me new units, but the same chemical. We're going from grams of ethane to what of the same chemical? Tell me in the chat. Same chemical units. Awesome. I see Micah coming in with it. Let's get some more answers. Again, we're right here in this middle step right here. Yeah, exactly. So the same chemical would still be C2H6, still ethane, but now we're at moles of that. And that is really important because once we're at moles, we can change to something new, right? So that's what's important. Moles to moles, the middle here is the most important part of our roadmap. So I'm going to get rid of grams here. Remember that this conversion ratio has to come from something that's always standardized or always true. So tell me in the chat what goes next to moles. Next to moles, I have a blank. So that should be what? Thank you, Micah. This one you will need to finish on your own, so please make sure that you are practicing with us. All right? You have 3 problems you need to finish on your own, so please make sure you're practicing. Yeah, 1. And what number goes next to grams on the bottom? Again, not this one up here. We need to look at something that's always true. Whereas up here, you won't always have 75 grams of ethane. That could change, but the molar mass won't. So what is always true about the molar mass here? How many grams are in molar mass? Thank you, Landon. Thank you, Micah. Yes, Ronnie. Yeah, so 30.07 grams is always in our molar mass. So that should go on the bottom here. Excellent. So we've gotten rid of grams of ethane. I'm at moles of ethane. That is not what I'm solving for. I want to get rid of that. That goes on the bottom of the next step. And on top, finally, remind me again, what am I solving for? How many what? Let's get lots of answers in the chat. What am I solving for? Tell me in the chat. Mary Jane, Angelo, Josiah, David, John, Dima. What are we solving for? Yes, we're solving for moles of oxygen, right? We said how many moles of oxygen. So MOL space O2, that's what goes on top. That gets rid of our moles of ethane, but we do need to fill this in. Remember, when we fill this in, moles to moles always comes from the balanced equation. So checking that out, what number should go next to O2 on top? Take a look at its coefficient. How many moles of O2 are in the equation? Yep, there are 7. And how many moles of C2H6 are in the equation? How many moles of C2H6 ethane are in the equation? 2. Beautiful. All right, so that being said, what we have is we have numbers on top, we have numbers on the bottom, and we're left with moles of O2, which is exactly what I was supposed to be solving for, the moles of O2. So let's finish this up. You need to be able to finish this, so please multiply what you get on top, 75 times 1 times 7. Don't put answers in the main chat. If you want to check, we're in the Q&A chat. And multiply what's on the bottom, 1 times 30.07 times 2. Then do the top divided by the bottom to solve your first box, which is the number. Your second box should be MOL space O2. That's your units. This is number 5. You have 45 seconds. Go, go, go.
Our question here says, how many grams of ammonia NH3 are produced by 4.6 moles of hydrogen? All right. If you are able to participate in the main chat, go ahead and tell me, what is it that we are starting with? What do they give us to start with? Give me the amount, the unit, and the compound. The amount, the unit, and the compound. Starting with, like that specific number. Yeah. Thank you, Dima. Anyone else want to answer that? Yeah, so it's going to be 4.6 moles of hydrogen, H2. That goes up here, right? And anything that is blank over a blank space, that will be just 1. And so now, right, what are we ending with, right? What is the thing that they tell us to find? What is this right here? Who can tell me in the chat? What are they telling us to find? So our middle step, if people can, for me really quick, go ahead, use your color pointer and point to the middle step, right? Where is our pit stop gonna be? No, not quite. That's our start. I'll type a little reminder. That's our start. Where is our pit stop? Where is it in the middle? What's that middle step? What's in between? Exactly. It's going to be moles of Y, right? So somewhere we're going to need a mole conversion. So that mole conversion is going to come from right here. So let me just take that away for a bit. It's going to come from the chemical equation. So what goes on the top, right, is going to be what we're looking for, and what we're looking for is ammonia. So in the equation, right, the number that's in front of ammonia, that big number is what? Really quick in the chat. Who can tell me before I type it? Right, that 3 right there on the top. And what we want to get rid of goes on the bottom, which is already moles of H2. So how many moles of H2 do we have? Can anyone tell me there? How many moles of H2? Exactly, Micah. That's going to be 3. So we have 2 over 3 so far. And then our final conversion, right, is going to be that final step with the molar mass to get mass of Y. So our molar mass is going to come from right here. All right, it could be on a test that you might need to calculate this, but we've already reviewed how to do that. So we're just going to plug it in to our, right, and that's going to be going on the top. So 17.03 grams of NH3, because that's the other part of the fraction. So moles of NH3, and it's per mole, right? So it's implied that it's just 1. Great. So now, everyone, go ahead and take your time and go ahead and calculate this. So we have 4.6 over 1 times with a 2, that's over a 3, times a 17.03 over 1. We put them all together right here. So just multiply everything that's on top, multiply everything that's on the bottom. Go ahead and divide those because it's just a fraction. And then your final answer will go with the units grams of NH3.
All right, everyone. Sorry, still helping people in the Q&A chat. All right, let's go ahead and take a look at this one. So how many moles of O2 are needed to form 325 grams of diphosphorous pentoxide? We can see an equation here as well as a molar mass that we will be needing. So taking a look here, what are we starting with? Tell me in the chat, what are we starting with? Give me a number, units, and the chemical, you can just use the abbreviation for the chemical. I know that's a long word. I know it takes a little bit of time to type, so make sure you just give me that chemical formula. Awesome. I see Micah in the chat. So here's our number. Give me units, give me chemical. Let's go, everyone. Need participation. Beautiful. Yes, awesome. I see Landon in the chat. Perfect. Yes, exactly. So that's what we're solving for right here, grams of diphosphorous pentoxide. So over here, I'm going to make the pink side P2O5, our diphosphorous pentoxide. And again, we're starting out with mass. So that's going to be the one that I circle here to start us out with. Now, what am I ending with? How many what? What am I solving for? Give me units, give me chemical. Units and chemical. Awesome. I see Micah in the chat. John, I don't know what you're writing. Please make sure that you're following along with us. What do you mean? How many what? How many blank of blank? Tell me, everyone in the chat. Let's go. Callie, Ronnie, Allie, Elijah, Douglas. Thank you, Ronnie. Jessica. Narish, Jaden. David, John, what are we solving for? How many what? Yeah, we're solving for O2, and this is a new chemical, so I'm going to make that my blue side. And again, moles of O2 means that we're right here. Perfect. Point for me on the board. What's the middle step? What's the middle step? Find the step in between the two circles we just did. Step in between the two circles. In between my two red circles. In between. Purple. In between my two red circles. Awesome. There we go. I see red up there. I see pink up there. Let's get some more answers. Greens and yellows. Get your arrows up there. Thank you. I see a green up there. I see another green. Let's get some yellows. There we go. Perfect. Yes. So taking a look here, our middle step is first, we have to get to moles of the same chemical. Before you can go to moles of a new chemical, you first have to get to moles of the same chemical. Let's do it. So up here, I've got 325 grams of P2O5 all over 1, just to turn it into a fraction. Doesn't change its identity. It's still the same thing. In the next step, I want to get rid of grams of P2O5. It needs to go where? Go ahead and tell me in the chat. In the next step, I want to get rid of it. That goes where? Thank you, Landon. Everyone should know this. Yes, it goes on the bottom. Grams of P2O5 goes on the bottom. And what goes on top? Again, before I can get to moles of a new chemical, I first need moles of the same chemical. So give me units. Give me the new units with the same chemical. New units, same chemical. What are we solving for in the middle step? Middle step right here. I'm starring it up on the board. Middle step right there. New units, same chemical. Yes, I see Landon. I see Micah coming in with it. Again, new unit, same chemical. Yeah, so we're solving for the new units, which is moles, but still the same chemical, so still diphosphorous pentoxide. Smiley faces emojis, everyone, if that makes sense. Again, you cannot change to a new chemical until you're first into moles of the same chemical. Great. Now this has moles and grams. That means I need a molar mass. I need something with moles and grams, something that's standardized and always true. What goes next to moles? Next to moles right here, I have a blank. Blanks mean what? Blanks mean what? Blanks always mean 1, and what should go next to grams? Again, from my standardized always true statement here. Do not get it from the question, because remember, the question could change. The question could change, so we need something that does not change. What is next to grams? Always in our molar mass. Thank you. I see Landon. Need more answers. Let's go. Marina, Allie, Karime, Jessica. Thank you, Monse. Thank you, Micah. Thank you, Ronnie. Waiting on John, David. John, David. Dima, Jaden, Narish. Thank you, Karime, Jessica. Yeah, so next to grams here, we can see the number 100. Oops, sorry. Here we go. 141.94. So that goes on the bottom right here. So I'm now at moles of diphosphorous pentoxide. So now I can get to moles of something new, right? Now we're at the magic mole ratio. That's awesome. So I want to get rid of moles of diphosphorous pentoxide. So that goes on the bottom. What goes on top? Again, what am I solving for? How many what? How many what? We already identified this. Tell me again, what are we solving for? Units and chemical. Units and chemical. Yeah, don't forget those units though, Ronnie. Again, it's going to be moles of O2. Moles of O2 go on the top. So that'll get rid of our moles of diphosphorous pentoxide, but I do need to fill in this mole ratio. Mole ratio always has to come from something that's always true. That's going to be our chemical equation. How many moles of O2 are in the equation? How many moles of O2 are in the equation? Yes, Dima. Yes, Landon. Let's get some more answers. Perfect. Lots of people confident with that. Yeah, there's 5. And how many moles of diphosphorous pentoxide are in the equation? Take a look at that one. What we put on the bottom, yep, that's going to be a 2. Excellent. So I've gotten rid of everything except for moles of O2, which is absolutely what I was supposed to be solving for. We have our numbers. Let's finish it up. So on top, 325 times 1 times 5. That's what you need to put on top. Calculate that first. On the bottom, then calculate 1 times 141.94 times 2. Then finally do the top number divided by the bottom number. That should give you your number here. Your units are MOL space O2 for number 7. You have 45 seconds to work on that. Again, if you need help, we're in the Q&A area. Go, go, go.
Stoichiometry calculations using molar mass and mole ratios. So if you like to use your color pointer, tell us how you feel about today, just briefly. All right. But just a reminder, we do have optional office hours still being offered. So be sure you take advantage of those. All right. So if you haven't already, go ahead and submit your notes. Have a great day, everyone. We'll see you back again on Friday. Keep in mind, tomorrow is a work day. All right. Have a good one.